Good morning, this is Dhaka Meenakshi. Now we are going to say about constraint layout advanced features. Now I am going to say about introduction and what is constraint layout, why we use it, and advanced features, chains, guidelines and barriers, and constraint dimension ratio and constraint bias, practical steps and real world applications. My name is D. Meenakshi. My roll number is 23056 and from AI section, and my topic is constraint layout advanced features. Course in mobile application development. First, we'll go with what is constraint layout. As you know, first we will go and learn what is meant by view. View is nothing but a basic building block so that user can interact with. And what is meant by constraint layout? Constraint layout arranges the view horizontally or vertically. In between them, there will be the constraint layout. It is a powerful layout in an Android that helps to design complex and responsive UI using the constraints between the views without nesting multiple layouts. This is the example of constraint layout, which is buttons. Now, why we use the constraint layout? So we have many advantages, not only these four, like improve the performance, easy to design virtually, like fully supported by the layout editor in Android Studio, highly flexible, always complex UI positioning and alignment with simple constraints. Adaptive layouts automatically adjust to various screen sizes and orientations. Not only this, as we mentioned, flag layout hierarchy, which is used for better performance and also reduces nested layouts, and also fixable positioning and using the built-in tools like guidelines, chains, and barriers, and it can be used for different screen sizes. Now we are going to see advanced feature. First, what is meant by chain? Chain it is used to arrange multiple views in a row or column with equal spacing. Guidelines. Invisible positioning are invisible lines used to align multiple views easily. Barriers. Dynamic references that adjust automatically based upon the size of other views. And view based upon the size of other view. And now we are going to see about group. Group is used to organize multiple views together so you can show, hide or change the visibility of other views with a single command. And now we are going to see about constraint bias. Constraint bias is used to adjust the position of a view between the two constraints. Constraint dimension ratio maintain the as per the constraint ratio. First, we are going to see what is meant by chain. As you know, chain. Chain allows the multiple views horizontally, means nothing but in row, or vertically, which is column, maintaining the order and equal spacing between the views. And we have the types of views like spread, equal spacing of views, spread inside, equal space within the boundary, packed, views packed together without space. Now we'll follow the guidelines. So, what is meant by guideline? A guideline is an invisible line in a constraint layout used to align or a positioning of a views consistently. And we have vertical guideline and horizontal guideline. As you know, in the code, we are going to um, step-by-step explanation of each line. As you know, Android constraint layout. This line declares a guideline element, Android ID. This gives the guideline a unique ID. You can reference this ID in an XML. Next, Android orientation sets the direction of the guideline. And next, app layout. This places the vertical guideline at 30% of total width of parent layout. It means the line will appear 30% from the left edge of the screen, and we are going to close the guideline tag since there are no inner elements. And now we are going to discuss about the barriers. A barrier is a virtual helper object that creates a dynamic constraint line based upon the size and position of multiple views. And here the step-by-step explanation. This line declares a barrier between this line declares a barrier view uh, helper from the constraint layout package. And Android ID aligns or assigns an ID to the barrier so that other views can reference it. Next, app barrier direction defines the direction of the barrier that works in. End means the barrier will be positioned at the end of the all reference views. Start means left edge of the reference views. Right means Start means left edge of the reference view. Right edge of the reference view means end. Top means top end. Top edge. Bottom means bottom edge. And we are going to list the IDs of the views that is barrier depends on, and then we are going to close it. Then we will discuss about constraint dimension ratio used to maintain a fixed width to height ratio. As width to height ratio is 16:9, that is the ratio which we'll be describing in the code. Like app layout constraint dimension ratio, this attribute is used to maintain a fixed width to height ratio for the view. It ensures that one dimension changes, the other adjusts automatically to preserve the ratio. Constraint bias adjusts the position of a view between the two constraints. Value 0 is equal to start, 1 is equal to end. What is the starting and ending position of a view between the two constraints? Practical demo step will be opening the Android, and we are going to create a new project and empty activity. Then we are going to open main activity and Kotlin, and we are going to design the buttons and test view in the open main activity, and we'll apply these all changes which we listed before, and we'll be running the app. And we'll be using the real world applications like modern app dashboards or login registered screens, responsive UI for multi-devices screens, and dynamic layouts in news or chat apps. We'll discuss the code at hand so that it will be easy to implement once. Integration, what is the future scope of constraint layout means improve the support for Jetpack, and it is used for advanced UI design with constraint layout, and it is used for animations. We'll recap it like what is meant by constraint layout. As you can see, it arranges the views horizontally or vertically. In between them, constraint layouts are being used. And it supports the chains, guidelines, barriers, ratios. So the chains arranges the view um, horizontally or vertically, which is meant by row or column with equal spacing. And guidelines is an invisible line, as you know, that also arranges the view. And we discussed as before ratios, and it enhances the performance and flexibility, essential for modern responsible Android apps. So this is the code we are going to see. Mm, First, we're going to see about the Kotlin code. Mm, First, we'll include all the libraries one by one. One second. Mm. First, package com dot example my application name of the app, and we are importing the required classes such as app combined activity, based activity, class for Android apps, bundle, used for saving and restoring the activity state, view, required to change the visibility, group, allows you to manipulate multiple views in a constraint layout at once. Class main activity defines the main activity class inheritance from app compact activity. Now we are going to discuss about override, super on create and set content view. On create is called when activity is created. Set content view sets the layout file. Activity XML for this activity. Value group. Fix find view by ID. Find the group view from the layout using this ID group info. The group contains information of test views in your XML. Group dot post layout. Post layout runs the class after a delay. Checks if the group is visible inside the lambda. If visible, sets it to the gone and hides all the views in a group. If it is hidden, set the view to visible, shows the all the views in a group. And now we are going to discuss about activity main, which is the important step for designing the UI design in the constraint layout. So we'll discuss it step by step as we discussed it before. As you can see, here the sum of the information of the activity main. So that starting we'll be using the constraint layout. This is the main parent layout, allows you to position and align the elements using the constraint layout rather than the nested layout. And then we'll be using the Android test view, like test view. Sorry. Before that, we are being using the Android ID, Android layout, and Android layout height. I'll gives the layout and ID, fills the screen, adds the padding, and links to the main activity. And next, we are going to do with test view. Android ID, Android layout, as you know before, a bold title center horizontally. Android with determined by the constraints. Next, Android aligns the top left and right edges to the parents and centers the title horizontally at the top. And vertical guideline we are going to say. Vertical guideline creates an invisible vertical line at the 30% of the parent width used to position views related to. Means we are going to use the guideline element in constraint layout package as we discussed before. That's why I'm going to say a bit fast. And horizontal guideline adds an horizontal line 20% from the top. Helps the position elements like the images and buttons below, below a specific section. Image view. Image For image view, we added ID, layout width, height, screen, background, and scale type. Image that sketches to the fit the space but keeps portions. And constraint between the top and right. and its ratio is 16:9 as we said before. And we included barrier. As you know, barrier, a short text label below the image, a longer text label placed beside the first one, and creates a dynamic invisible line after the longest of the two text views. If one grows longer, the barrier automatically grows. And last one, we included the test button, two test items placed vertically. And this is the output we got. So we indicated no color so that it got black and white. And here the image should be appearing, and here is the information. Thank you.